So welcome to all of you in video based IT training. In this video I'm going to demonstrate about EIGRP, stand for Enhanced Interior Gateway Routing Protocol. Okay. Second point, hybrid protocol means it take all the best feature from two other category, that is distance vector and link state protocol. Third point, so it's also known as advanced distance vector protocol. Okay. Cisco proprietary. Initially it was a Cisco proprietary, but nowadays it become an open protocol, means you can configure EIGRP either on the Cisco as well as Juniper or any other brand router for the routing purpose. Default matrices, it use bandwidth and delay to calculate the best path from any source to any destination. Load and reliability is the optional, means initially it is considered as 0, only bandwidth and delay is considered as 1 to calculate the best path. Maximum hop count is 255, but by default it works on the 100. Okay, by default it works on the 100. Manually we can set it up to 255. Only the one routing protocol that can work in IP, IPX as well as AppleTalk environment. No other protocol, either RIP or OSPF, can work in IP and IPX. All other protocol can work in IP environment only. Only the EIGRP can work in all three environments. It uses triggered update. Triggered update means like RIP keeps sending its routing table to its neighbor after each 30 seconds. That is the update timer. But EIGRP only sends any update to its neighbor when there is some change in topology. It instantly sends any change to its neighbor. It will not wait for any update timer. As soon as there is some change in the topology, it instantly informs its neighbor. To internal protocol works, that is RTP and DUAL. RTP stands for Reliable Transport Protocol. So it do a reliable communication with the help of RTP protocol, and for the best path selection it use DUAL, diffusing update algorithm. So I will come back on this protocol later. It also support VLSM and subnetting. It's a classless protocol, so when it send any information to its neighbor, it also include the subnet mask in that. Fast convergence. Fast convergence means due to this triggered update, as soon as there is some change in the topology, it inform to its neighbor. So due to this reason, it's have a very fast convergence, means all the database in all the router is synchronized, equal routing table. Only one protocol that support unequal cost path for load balancing. All other, either RIP, OSPF, can support equal cost path for load balancing. Only one protocol that support unequal cost path, that is EIGRP, for the load balancing purpose, and works on Bellman-Ford algorithm. Means entire algorithm was designed by Bellman and Ford. So very first step, as soon as we configure any of the router with EIGRP protocol, the very first step is the neighbor discovery. It does means like in the RIP, as soon as we configure RIP on any of the router, it start exchanging its routing table with its neighbor. So it maintain only one table, that is the routing table. But in case of EIGRP, very first step is to establish the neighborship with the another EIGRP configured router. It use hello packets for that purpose. It use hello packet for the neighbor discovery. 3 condition must match to become a neighbor. So that 3 condition is the hello and acknowledgement receipt. Means as you configure EIGRP on any router, it send a hello message to its neighbor. So to become the neighbor when he's sending the hello and acknowledgement must received. Second parameter that must match to become the neighbor is AS number. AS number means autonomous system number. I have explained about the AS number in my previous video. What is AS number? All the router coming under a common administrative domain. So AS number must match to become a neighbor. Third point, all metrics must match on all the router participating there. Means matrices value K1, K2 means delay, bandwidth, load and reliability must be same. Means if one of the bandwidth configured on one router interface, same bandwidth should be configured on another router. So these are first step in the EIGRP is the neighbor discovery. So as explained you, three conditions must match to become a neighbor. Hello and acknowledgement received, AS number must match, and all matrices must match on all the router participating there. So come on, some of the common EIGRP terminology. Till yet, either in the case of RIP, we have learned about only one table, that is the routing table. But EIGRP maintain three different tables: neighbor table, topology table, and after that routing table. So what does it mean? Neighbor table. Each router maintains a neighbor table that lists adjacent router. What does it mean? Just come on this particular. This router have two directly connected routers. One is this one and one is this one. Okay. So as soon as all these three routers configured with EIGRP and all the three conditions that I have discussed previously, was hello and acknowledgement, AS number, and third one is the all matrices should be same. All these three conditions match, so each router start maintaining its neighbor table. So later I will show you the example of neighbor table also when we do the practical. So in this case means this particular router have two directly connected routers. One is this one, so one is this one. So means now in the neighbor table it will keep two database. One is this router directly connected and one is this neighbor. Second, topology table. Every EIGRP router maintain a topology table for each configured protocol. Means like to reach from this router to this router, it have two paths, one via this router and one via this router, like this and like this. So means this router have now two paths to reach up to this router. So it will keep the entire network topology to reach from one network to another network in its topology table. What is the benefit of that? In case one of the route path become down, it have the alternate path to reach up to that particular network. All learn routes to destination are maintained in the topology table. Third is the routing table. As I have discussed many times in my previous video, it choose one of the best path to reach to a destination from a topology. Means EIGRP choose a best route to a destination from the topology table and place this route in the routing table. Topology table has the entire topology, so EIGRP choose one best path and put it on the routing table. Each EIGRP route maintain a routing table for each network protocol. Got it? So there are the three main table: neighbor table means directly connected route router, topology table, entire topology about the network, keep all the path from any source to any destination in its topology table. From that all the path, it choose one of the best path and put it into the routing table. Now successor, what is successor? As I've told you, topology, from the topology table it choose one of the best path that has been shifted to routing table. That best path is known as the successor path. A successor is a route selected as a primary route to use to reach a destination. Successors are the entry kept into the routing table. Okay, and feasible successor means second best path. Feasible successor is the backup route for the successor. Got it? So these are some common topologies, common terminologies for the EIGRP. So in my practical scenario, I'm going to use this particular topology, having different networks like 10 network, okay, 12, 11, and every so many routers, so many different networks, and I will configure EIGRP on this. As you can see here, as I told you, neighbor table. So when I run, after configuring EIGRP, when I run command show IP EIGRP neighbors, so it will show you the entire address, like on serial 0 port, address is this one, so it is connected with neighbor, and 1.2 is the second connected on Ethernet 0. So this is a neighbor table. Each EIGRP router maintain a neighbor table that is adjacent routers. So whenever a new neighbor is discovered, the address of that neighbor and the interface used to reach the recorded in the neighbor table entry. Okay. There are so many options available here, like neighbor address is this one, queue count, the number of packet waiting for the queue to be sent, means the number of packet that has to be sent via that particular. If a value is constantly higher than 0, okay, so it means there are congestion or problem at the router. 0 means that there is no EIGRP packet in the queue. Okay, you can see so many smooth round trip timer, the average timer it take to send and receive the packet from the neighbor. Hold down timer, the interval to wait without receiving anything from a neighbor before considering the link to be unavailable. So it will keep waiting up to the hold down timer, hold down time, till it keep waiting for any of the information from the neighbor. Topology table, sure, you can see here successor path, and this is the second feasible distance, okay, which two successors. Okay, so it have two paths to reach from any source to any destination. It have the entire topology of the network. Each EIGRP router maintain a topology table for each configured network protocol. Each table include route entries for all the destination that the router has learned. All learned routes to the destination are maintained in the topology table. Okay, and last is the routing table. Perhaps I've explained in my last videos also. So here you can see this is the destination D. D stand for path find out by the EIGRP router. This is the administrative distance, okay, and the second parameter, this is the matrices calculated via EIGRP to reach to any destination. It is connected via this particular IP, means next hop address, and this interface. Okay, so this is all about the routing table. The routing table contains the route installed by DUAL. DUAL is the diffusing update algorithm to find out the best path and best loop free path to a given destination. EIGRP will maintain 4 routes per destination. So in the topology table, EIGRP keep 4 paths to reach to any destination. This route can be equal, as I've told you previously. It support equal as well as unequal cost path for load balancing. Like this, you can see here. This is the formula to calculate the matrices. As I've told you, bandwidth and delay is the main parameters, and reliability load is the optional. So default consent value for this is, you can see here, K1, K2, K3, K4, K5. K1 is the bandwidth, so it is considered as 1, as I've told you previously. K2 is load, it is considered as 0 by default, it is optional. K3 is the delay, you can see K3 is the 1. K4, K5 is the reliability, that is the optional. Initially it is considered as 0, so matrix is calculated on the bandwidth plus delay. Okay, so EIGRP is really beautiful protocol. So very first time, it does not keep sending, as I've told, it's not keep sending the updates this neighbor time to time. It's very much resource as well as bandwidth conscious. It try to consume as much as possible. The only EIGRP, the only time the EIGRP advertise its routing table when it discover a new neighbor and form an adjacency with its neighbor of hello packets. So very first time when you find a new neighbor, it sends its entire routing table to its neighbor and form an adjacency through exchange of hello packets. When this happens, both neighbor advertise their entire routing table to one another. After each has learned its neighbor routes, only the change in the topology will be propagated down. Every time it exchanges some information with its neighbor, it does not send the entire routing table because it's very much bandwidth conscious. It only sends the change to its neighbor. Yes, this particular new network come into the network. Okay, so only first time when new neighbor come, it exchange its routing table to the neighbor. Once both the router are the synchronized state, after that it only send partial update to its neighbor. So there are two type of update. One is a full update only first time, and partial update after that when there is some change in topology. This is a partial bounded update to consume minimum bandwidth consumption. So EIGRP very intelligent protocol. Not only initial stages, after the database has been working properly, it take care for the bandwidth. So now come on to the RTP. As in the starting I've told you, EIGRP use two internal protocol. One is the RTP and one is the DUAL. RTP stand for Reliable Transport Protocol. Manage the delivery and reception of EIGRP packet. Reliable delivery means that delivery of guaranteed, and that packet will be delivered in order. So very first, for the reliable delivery, it used one of the internal protocol, that is the RTP. Initially, it used a multicast. As soon as you configure EIGRP on any of the router, it creates a multicast group having the frequency of 224.0.0.10. So it keeps sending, like, to keep maintaining the relationship, hello packet at the frequency of 224.0.0.10 multicast IP. Each neighbor receiving a reliable multicast packet and will unicast an acknowledgement. One of the router send multicast message to all the neighbors and then acknowledgement given by the unicast. And last is the dual diffusing update algorithm. ensure that a given route is recalculated globally whenever it might cause a routing loop. Means in normal language you can say it is responsible for the to find out the different route, recovery of paths to any source to any destination, support VLSM, and to give a best loop free path to a router. Okay, you can see here EIGRP is responsible for the routing within the AS numbers, and DUAL respond to the change in routing topology and dynamically adjust the routing table of the router automatically. So you keep updating the routing table of the router automatically by finding the best path, new path, any path recovery, and anything if there is any change in the topology. So when no feasible route means one is a successor and then is a feasible successor to a destination, the DUAL algorithm invoke a diffusing computation to ensure that all traces of the problematic route are eliminated from the network, at which point, very good point, at which point the normal Bellman-Ford algorithm is used to recover a new route. So it is the entire responsibility of DUAL algorithm to keep updating the routing table, to keep finding out the new paths. Okay. So after that I'm going to do a practical demonstration how we can configure EIGRP. So I'm going to use this topology. As you can see here, I just do the basic configurations. You can see here, just come on this router. So to check enable show running, you can see here I have just do the basic configuration, means IP configuration, no routing protocol, nothing else has been configured on any of the router. Show running, oh sorry, show running, only basic configurations, and I'll check show IP route, only directly connected network here, no routing has been done. This router also, show IP route, only directly connected network, show running, only basic configuration has been done. So I'm going to use, as I've told you, AS number must match to become the neighbor. So I'm going to use AS number. You can choose anyone in this practical demonstration. So I'm going to use 20. Okay. So AS number should be same on all the router and everything. So come to the configure terminal, router EIGRP. So basic command to configure the EIGRP router is this one. After that you have to mention, like you can see here, AS number. Okay, so in this case I'm going to use the AS number 20. After that, the interface to which you want that participate in the EIGRP process. So one is serial 1 by 0 and serial 1 by 1. Directly connected network is 10 and 12. So which particular network you want to include in this particular process? So one is a 10 network and one is the 20 network. Then simple. So here was only two directly connected network. One is the 10 and one is the 12. Sorry, 12 and 11. You can also verify with this command show IP route. Okay, just I need to configure terminal router EIGRP 20 no network. By mistake I have given the 20, there is no 20 network. 20.0.0.0. I have already configured 10 network. Okay, so 10 is directly connected. Next is 11 and 12. Network 11.0.0.0, 12.0.0. Network 12.0.0.0. Done. Show IP route. Nothing, because neighbor has been not configured. This neighbor and this neighbor is not configured with the EIGRP, so they are not sending hello packets and not become the neighbor till this has been configured. Conf router EIGRP AS number should be same to become the neighbor. So in the last router, first router, I have configured the autonomous system number 20. It should be same. Remain same process. Network 10.0.0.0. Looks something happen now. Yes, because 10 has been configured, so it find a neighbor 10.1 and new adjacency had been found with the help of DUAL. Correct now? Everything is clear I think right now. With the help of dual concept, it found a new path, it found a new neighbor. Network 13.0.0.0 and network 17, that is directly connected network. Got it now? So these are directly connected network, and particularly in another word you can say which particular network I want to include in this particular EIGRP process. Done. I've done this. Come on this router also. Show IP route. 12, 14 and 15 is directly connected. Conf T, same process, router EIGRP. Again ES number should be same on all the routers. 20 network 12.0.0.0. Yes, again it found a one new neighbor and for new adjacency with the protocol dual EIGRP ES number 20. Network 12 has been configured. 14.0.0.0. Network 15.0.0.0. Come on the fourth router in the similar way. Show IP route, verify the routes. Yes. Now conf T, same process, router EIGRP, same again, AS number should be same. Network 13.0.0.0. Yes, instantly it find one new neighbors with the help of dual. Network 13 has been done. 14.0.0.0. Again it finds on the second interface find the path, new neighbor, and last one is 16. I think done. So check show IP route. Ooh, yes. Look here. Now this router have information about all the D means path find out by the EIGRP. You can verify here. 90 is the administrative distance and this is the path matrices to calculate the best path. Like from this router to reach up to 11 is the this router path. So now you can see here it have two paths to reach to that particular network. Means you can see here 13.1 and 14.1. 13.1 is this interface and 14.1 is this interface. So reach up to this particular network. Now this router have two paths. One via one via this path and go to here to reach up to the 11 network, and second from here to here it can also reach to the 11 network. Okay na? So these are the two paths, and same thing it is showing that it can reach up to the 11 network by two paths. One is the 13 and one is the 14. Check this routing table also. Show IP route. This also have the two path to reach up to 16. 16 is this network, so it can go via this path also and can go via this path also. So it again have the two paths to reach up to 16 network. In a similar way you can verify from all the routers. Okay, I think clear. I want to show you something more. Check on another. Show IP route. Same thing here. Show IP EIGRP neighbor. You remember that, na? So it have two neighbors, this one and this one. Show IP EIGRP topology. So you can see this is a passive and it have two paths to reach up to destination. So in this way EIGRP is really smart and very intelligent routing protocol to reach up, find out the path. So hope you enjoy this video. Thank you very much.